In this video, I'll be comparing a number of different IR cut filters to allow you to take normal visible light photos and video on a full spectrum converted camera. The camera I'm testing these on is the Canon R5. It's important to note that different camera manufacturers use different sensor glass stacks, and they optimise their output based on those stacks. So the best filter to make a full spectrum converted Canon camera give images like an unconverted one will not necessarily be the same filter that you would want to make a full spectrum converted Sony camera to give images like an unconverted one, for example. The filters I'll be looking at are the TSN 575 in 2mm thickness, the Fotga UVIR cut in 0.75mm thickness, the B&W 486 UVIR cut, which is 2.2mm thick, the Tiffen Standard Hot Mirror, which has glass 2.4mm thick, the QB39, also known as the BG39 in 1mm thickness, the QB40, also known as the BG40 in 1.5mm thickness, the QB26 in 2mm thickness, the BCF filter from Tangxinhua in 1.2mm thickness, the Tangxinhua ICF in 2mm thickness, QB21 in 2mm thickness and QB21 in 3mm thickness, and also an unconverted Sony A7 IV as an example of what the image should look like. A couple of IR cut filters I have but didn't include in this test are the Tiffen T1 IR cut and the SLR Magic Image Enhancer Pro. I've previously tested both of these and they seem like they're designed for unconverted cameras that have a slightly IR leaky sensor filter stack, like some of the earlier Blackmagic cameras. They don't really cut enough IR to be useful for visible light photography with a full spectrum converted camera. We'll start off with the main test, which is comparing colour. I photographed a colour checker against a black fleece background. The fleece is used to help determine IR leak, as it appears brighter in infrared than it does in visible light. The white PTFE disc was used for setting white balance for each image, which was done when converting the raw images and not in camera. The bit of card with paint on was my attempt at an IR colour checker, but it can basically be ignored as it doesn't tell us anything useful in this test. The images were lit using a full spectrum modified AD200 flash, which I think gives a similar output to daylight. Flash power was varied as needed between the filters. The RAW files were converted in Adobe Camera Raw, and the exposure slider was then used to adjust the darker middle grey patch of the colour checker to RGB values around 102. 102 is the value that I got from a colour checker generated from the colour checker data provided by X-Rite, so that's why I used that value. The photos were then exported as 16-bit TIFFs in the ProPhoto RGB colour space. Using Patch Tool, the colour checker data was extracted from each image and then compared against the colour checker data from X-Rite. The large colour patches you can see here show the X-Rite provided colours as the top right triangle of each patch, and the bottom left triangle is the colour extracted from the image. The number in each patch is the delta E between the two. Then I also compared the hue, saturation and luminance values between the two as well. For these I just measured the main 6 colour patches, the darker middle grey patch and the background. These were just measured using the colour picker tool in Photoshop. The comparison is done against the values from a colour target generated by Patch Tool from the X-Rite provided colour checker data. The background obviously wasn't included in that, so this is just compared against the background in the Sony image. The Sony image was taken with the Sony 55 1.8 lens, and the Canon images were taken with the Canon RF50 1.8 lens. So starting here with the Sony image, we can see that the colour checker values aren't actually that close to what they should be according to X-Rite, but this gives us a good baseline as to what we should expect for a good result from the filters. Because the delta E values were so high on the Sony image, I tried a custom tone curve to get each of the neutral patches on the right hand side of the colour checker as close to their correct luminance values as I could. I didn't adjust the colour at all. As you can see from the calculated delta E values in this image, while this has improved the scores for the neutral patches, the rest of the patches are arguably worse. And so I didn't use this tone curve on any of the rest of the images. The TSN 575 is not really designed to be used as a visible light bandpass, but rather an IR cut filter that can be combined with other filters such as UV pass filters that leak IR. It cuts red light as well as IR, and we can see this in the red, pink and purple patches. The Fotga UVIR cut filter gives slightly more saturated colours than the unconverted Sony image, the red standing out particularly. The background looks good with no visible IR leak. I used the B&W 486 as my visible light filter for a long time, but here you can see that it does have a bit of an infrared leak. The background is more red and lighter than it should be. Like the Fotga, the colours, especially the red, are quite saturated. You can immediately see from the background that the Tiffen Standard Hot Mirror filter leaks a lot of infrared, so not a good choice for getting visible light images on a full spectrum camera. The QB39 or BG39, QB39 is the Chinese manufacturer's designation for this filter, and BG39 is the shot designation. This is the filter that I've been mainly using with my full spectrum Canon R5 for visible light work. It's also the filter that's generally recommended for getting visible light images on any brand of full spectrum camera. If we average the delta E's of the colour checker comparison, this filter gives us the lowest score, which is 6.99, compared to the unconverted camera, which is 5.7. Note that this filter passes UV as well as visible light, but there's so little UV light that gets through the atmosphere or output by a xenon flash tube in this example, compared to the amount of visible light, that it doesn't have a noticeable effect on the image. The QB40 is much like the QB39, except it lets through some deeper reds and a small amount of infrared. The QB26 cuts too much red, though it is not quite as strong as the TSN 575. The BCF filter is designed for astrophotography to let through the deep red of hydrogen alpha particles. As we'd expect from that, it leaks some infrared and the reds are oversaturated. So good for astrophotography, but not really good for normal visible light photography. The ICF, or internal cut filter from Tang Xinhua, is meant to be the same as QB21, but available with an anti-reflective coating. This gives a good result. Looking at the QB21 now, we can see it's not actually the same as the ICF, and these are both the same thickness of 2mm. The QB21 is cutting more of the deep red light. QB21 in 3mm thickness has an even stronger effect on cutting the reds. And finally, here is the camera with no filter for comparison. The background is quite bright and the colours are washed out from the large amount of infrared light being captured. The Fotga and B&W 486 UVIR cut filters are both interference-based dichroic filters. This means on wide-angle lenses you can get a cyan vignetting effect. So I wanted to test the filters for this. These were shot on a Canon EF 28mm lens on a generic EF to RF drop-in filter adapter. A 52 to 49mm step-down ring on the front of the lens was used for all shots. Most of the filters being tested are 49mm size and were screwed into the step-down ring, but for the larger filters these were just manually held against the step-down ring instead of having to use different stepping rings for each one. This was in an attempt to ensure that any vignetting caused by having to use a step-down ring for the 49mm filters would be consistent across all images, even those using the larger filters. But as you'll see from the shots, I didn't quite manage to get the larger filters centered perfectly, and so they sometimes have some vignetting from this. Still, it's more the green cyan vignetting than normal vignetting that we'll be looking at anyway. Images were processed in ACR with lens profile corrections turned off and white balanced on the PTFE disc. Starting with a full spectrum image, that is no filter, we can see a small amount of vignetting, but nothing bad. The TSN 575 looks fine in terms of vignetting. The Fotga UVIR cut has very pronounced green vignetting. The cyan green vignetting should be correctable using a flat, but this is another post-processing step, and if you use Adobe software like I do, it requires creating DNG copies of all your images, so it's not really a great solution. I wanted to test the filters behind the lens as well to see if this made any difference. This shot was taken using a 49mm size of the Fotga UVIR filter in the drop-in adapter behind the lens, and as you can see, it does make a big difference. The light rays are at much less of an angle as they exit the lens towards the sensor, and so the cyan vignetting caused by the dichroic coatings of the filter is greatly reduced. There's still a bit of the green cyan tint towards the edges and the corners, but it's much better than when the filter is used in front of the lens. The B&W 486 does not seem as bad as the Fotga when used in front of the lens, but it's still not very good. I don't have this filter in a small enough size to use behind the lens, but I would imagine it would be much better used like that. The Tiffen Hot Mirror filter surprised me by not having any cyan vignetting. When you look at the filter itself, it is quite reflective, like the Fotga and B&W 486 dichroic filters. But based on the results here, I would say that it must just have anti-reflective coatings, and it's not dichroic. QB39 looks good. As far as I'm aware, all the QB etc. glass filters from the Chinese manufacturers are uncoated, though they are starting to offer more filters with AR coatings, but this is always mentioned in the product name. Placing the filter behind the lens makes no difference. QB40 is much the same, no coloured vignetting is visible. Again, no difference if the filter is behind the lens. QB26 is the same again. The Tang-Sin-War BCF filter does have a little bit of cyan vignetting. If we put it behind the lens though, it clears up nicely. The Tang-Sin-War ICF is sold as being AR coated. We can see the coatings have no negative effect when used on a wide angle lens though. And as we'd expect, it's the same when used behind the lens. QB21 has no issues. I don't have a 2mm thickness of QB21 to test behind the lens, but based on the other results you can be pretty sure that it will give the same results as when used in front of the lens. 3mm thick QB21 similarly has no issues, and no issues when used behind the lens either. Now looking at a more extreme example using a 16mm focal length with the Fotga UVIR cut filter in front of the lens, and you can see the cyan vignetting is absolutely terrible. But switch to the filter behind the lens and it's fine. The results here actually seem slightly better than when it was used with the Canon EF 28 2.8 lens, so it seems how well a dichroic filter works behind the lens is dependent on how the lens is designed rather than how wide the focal length is. With the Canon 8-15mm fisheye set at 15mm, even an 82mm filter pushed right up against the front element is not large enough to avoid mechanical vignetting, and the cyan vignetting caused by a dichroic filter overwhelms the image. But place the filter behind the lens and there's no problem. A brief note that uncoated filters are susceptible to corrosion, as has happened to my QB40. I use silica gel packs in with my filters, but they're not kept in a dry cabinet. I will probably try and clean up the filter at some point with a soak in diluted hydrogen peroxide, but even if that does clear the corrosion, there's nothing to stop it coming back again or the same problem occurring to the QB39 and other similar filters. I wanted to test the filters to see if they introduced any lens flare. Unfortunately, this test isn't actually that useful because the lens that I'm testing with, which is the Canon 100mm 2.8 non-L macro, seems to flare quite easily even without any filters. I did test a couple of other lenses as well, but they're even worse, so this is the best lens that I had to test with. Anyway, I did the testing, so I'm including it here, but you might want to just skip this section. The Canon 100mm non-L macro lens has a filter thread of 58mm. 49mm filters when used in front of the lens for this test were using a 58 to 49mm step down ring, and larger diameter filters were used with step up rings. The target was lit with an LED light. The flashlight used to create the flare does seem to output infrared, but less IR as a proportion of the total light output compared to sunlight. White balance was set in camera using a sheet of white PTFE. Then each clip has been graded using the colour match tool in DaVinci to try and match the colour checker chips. The clips are sped up to 200% speed to prevent this section being too long. With the unconverted Sony and no filters on the lens, we see large amounts of veiling flare and some ghosting. With the converted Canon and no filters, I would say the ghosting is a bit worse and more distracting. With the TSN 575, the ghosting is worse still. The red colour of the flare is caused by grading based on the colour checker and DaVinci's attempt to compensate for the lack of red light that the TSN 575 passes. It's not an actual trait of the filter itself. The Fotga has similar style flare to no filter, but the flare is stronger. If we use the 49mm size Fotga UVIR cut in a drop-in filter adapter behind the lens, we get much worse ghosting. The B&W 486 used in front of the lens I would say is pretty similar to the Fotga used in front of the lens. These are both dichroic filters, though B&W and Fotga will be using different coatings. The Tiffen Hot Mirror I would say is similar to the B&W and Fotga, with a bit worse ghosting. The QB39 has even worse ghosting. It's important to note that my QB39 has a few chips around the edges of the glass, and it's also housed in a 3D printed filter ring. So both of these, especially the chipped glass, probably affect the flare. Behind the lens, the QB39 also gives bad results, and we see a large artifact around the light like we did with the Fotga when used as a drop-in filter. The QB40 has weird flare around the edges. Possibly the filter ring or retaining ring the glass is mounted in is causing this effect rather than the glass itself. Also note that my QB40 filter has corroded glass, which likely affects the flare. When used as a drop-in filter behind the lens, the flare is really terrible, like the other filters. QB26 is pretty similar to TSN 575 in terms of the flare, and the colour grading causing a red tint. Again, behind the lens it's even worse. The Tang Xinhua BCF seems quite good, relatively speaking. It appears this filter has some coatings that are helping it a bit. Behind the lens, the BCF filter has the same issue as all the others. The AR-coated ICF filter does seem better than the uncoated filters, but still worse than no filter at all. Behind the lens, we get the same problem of a large artifact around the light source. The 2mm thick QB21 is just as bad as the other uncoated filters. The 3mm thick QB21 is giving us especially bad flare around the edges of the images, just like we saw with the QB40. This glass is mounted in a similar way to the QB40, so it does appear that this is caused by the filter ring or retaining ring rather than the actual filter glass. Behind the lens, we get the same problem as the other filters behind the lens. The odd flaring around the edges is much better than when used in front of the lens though, probably because less angled light is going to be hitting the filter ring when it is behind the lens. So in conclusion, the 1mm thick QB39 does indeed seem to be the best filter for getting standard visible light images from the full spectrum converted Canon R5. I also like the Fotga UVIR cut and the deeper reds it gives, even if it may not be technically as accurate. The Fotga is also unlikely to suffer from corrosion and is available fairly cheaply on AliExpress in a range of different sizes. And importantly for me, the Fotga filter comes with slim filter rings. The QB39 is better for use on wide-angle lenses though. We saw the Fotga will work well in a drop-in filter adapter behind the lens on a wide-angle lens, but we also saw that lens flare can be really bad like this. The QB40 and ICF are both decent filters as well. The rest of the filters I would ignore in terms of visible light photography. As I mentioned previously, I did use the B&W 486 myself for a long time, and I was happy with its performance. But based on these tests, there's no reason to buy or use that filter when there are several alternatives that perform better. One last solution is simply to use a standard unconverted camera for visible light photography. In the past I've done this when on holiday, using an unconverted camera for normal photos and a converted one for infrared images with various filters. But for Vis UVIR flower comparison images, I like to always just use the one full spectrum camera and the appropriate filters.